Thank you for joining me for this video. We are looking here at the hexagon area formula derivation. I am Mr. Ish. I have previously presented this already, but thanks to an astute observer pointed out that my y-intercept in that previous video was flipped around. I am correcting everything and representing in this video. The derivation formula in the previous video is correct. I'm going to do everything here again, but we will make sure not to have that typo. In this video, we're looking here at a hexagon, and you can divide it into 6 equilateral triangles by means of what you see over here. When you look at these triangles, a single triangle, you can split it and generate some representation as this, where the trigonometric ratios come into play. It is by means of this trigonometric ratio that we can develop that hexagon formula, because it makes things easy. Given that each side is A, we can proceed with that. With regards to the area formula derivation, keep everything here in mind. Each of these angles is 120 degrees, but when you take out the triangle, those 120 degrees get split here into 60 degrees, as you can see. When you bring out one of those 6 triangles and put it here on an x and y plane, you're looking here at a side A, and then here. By means of those trigonometric ratios, this is where my error was in the previous video. I'd written root 3a over 2 comma 0, and obviously that's not a right form. You have to flip it around. So the correct value would be 0 comma root 3a over 2. The calculation, everything is correct in the previous video. I'm looking at this, but I'm writing that, and in my mind the computations are good because I'm still seeing the correct form, even though the typo persists for that video. But this right here is the correct version, 0 comma y and your y-intercept. You want to look at everything with regards to right and left boundary curves and their difference. The right boundary curve, the slope by means of all of these points here, slope would be minus root 3, then y is equal to minus root 3x plus your intercept root 3a over 2. You solve this for x, you'll have x is equal to y minus root 3a over 2 all divided by minus root 3. But when you impact it by means of that negative, you can flip it around. Your right boundary curve will become root 3a over 2 minus y divided by root 3. That's my right boundary curve. Your left boundary curve is almost the same because these are symmetric lines in terms of their symmetry around the y-axis, even though they have different slopes. You're looking at a positive root 3, therefore your left boundary curve will become y minus root 3a over 2 divided by root 3. That's exactly what it is, and the a is not under the radical, as you see. Your integral here with regards to the area is not hard. We're looking here with regards to y. Everything here is in the form of x. We're putting here a 6 because 6 of these triangles give you a hexagon. 0 up to this high point, which is root 3a over 2. Right boundary minus left boundary. But look, everything here will land easily under root 3 denominators. You'll have a right minus left, root 3a over 2 minus y minus your left, y minus root 3a over 2 dy. You can easily push this root 3 out, 6 over root 3. I can eliminate the denominator. Remember, these are repeat procedures from the previous video because my error in the previous video was right here. These things flipped around. Anyhow, root 3a over 2, that 2 root 3a over 2 minus y will be a minus 2y. That's exactly what it is. This right here is my integrand, but you can simplify it. You're getting a root 3a minus 2y. All of this in terms of the integrand boils down to that. The antiderivative here is easy. Your variable is y. Root 3ay minus 2y square over 2, which is a y square. You have this sitting outside, 6 over root 3 from an upper limit root 3a over 2 and a 0. Don't put a 0, it's meaningless. Now we do the calculation. Root 3a over 2 coming in here, multiplying by root 3a will give you a 3a square over 2. That's what you'll have. Root 3a over 2 squaring all of that will give you here a minus 3a square over 4. You know you still have this 6 over root 3 out. You do the computation, 6a square minus 3a square, which is a 3a square over 4 times 6 over root 3. Simplify everything here. 2 goes in here 2 times, 2 goes in here 6 3 times, root 3 goes in root 3 1 times, root 3 goes in 3 root 3 times. You can do it that way. You'll have 3 root 3a square over 2 as being the area of the hexagon, and I'm done with this derivation procedure. This entire area over here can be given by means of that formula, and my error from the previous video has been rectified, this being the error, the flip I had in the previous video, but the computations were good. Thank you for watching and giving me this chance to correct the error. Have a great day. Bye.